Greetings to everyone. Sanibonani, Dumelani, Abushini, Molweni. We are continuing with financial mathematics. Today we will be doing calculations involving changing interest and also calculations that involve additional payments and withdrawals. But before we can start with that, I would like us to look into the what to call two formulas that are available for compound investment and loans. So we will be having these two formulas that will be vital for the problems that we'll be doing in this lesson. As we know, this one is a compound formula. Now if you work out this compound formula and you make P to be the subject of the formula, like here, we are going to have something like this, and this is going to be a negative exponent. So the exponent is positive for what? For the accumulated value, because what called for the accumulated value calculations, and the movement on the timeline is from left to right because interest on the present value is being added. So we are going to discuss this also. The exponent is what? The exponent is negative for present value. For this one, the exponent is negative for present value calculations, and the movement on the timeline is from right to left because interest on the accumulated amount is being removed. Okay, so now with calculations involving changing interest rates, we're going to use the timelines. The timelines are useful when dealing with more complicated programs such as interest rate changes, or when several deposits are made into a savings account, or withdrawals are made from the account. Okay, now let us look into example 1 without any waste of time. What do we have here? A 30,000 is deposited into a savings account. The interest rate for the first 3 years of the savings is 12% per annum, compounded half yearly. Thereafter, the interest rate changes to 18% per annum, compounded monthly. The money is left to grow for a further 4 years. Calculate the future value of the investment at the end of the 7-year savings period. Okay, so before we start, we will have to represent all of this on a timeline. Okay, on our timeline is going to look like this. We are going to have 7 years. That is going to be it's going to look like this. We are going to have 1 2 3 4 5 6 7. Okay, this is going to be term number 0, and then this is going to be our first year, second year, third year, fourth year, fifth year, sixth year, and this is going to be our 7th year. So what are we being told? The interest rate for the first 3 years. Okay, for the first 3 years from year to year. Now we know that, okay, the interest here at this point, our interest at this point is how much? Is 12% per annum, compounded half yearly. So our interest here is going to be equal to 12% is 0.12 divide by 2. This is our interest for the first 3 years. Now for the remainder 4 years from 1 2 3 4, what do we have? Our interest is 18% per annum, compounded monthly. So this is going to be 0.18 divide by 12. Okay, so how did I get this 0.18 and that 0.12? From the previous lessons, we did 12 divided by 100 give us 0.12, the same as with 18. We are going to get 0.18. So we divide by half yearly, and then we say 2 because we've got 2 6 months in a year. and then we've got 12 months in a year. Okay, so the amount that was deposited, it's what is 30,000. so you start there. Well, we started with how much there? With 30,000 there. We've got 30,000 here. So what happens if the interest rate changes? If the interest rate changes, this is how our money, because this is here, we're trying to get what? We're trying to get A. As we were doing, we said if we are looking for A, the exponent is positive, because the movement from the timeline is from left to right. So the movement from the timeline is from left to right. So how is this money? We want to get there. So how is this money going to grow? If we've got a change in interest, our money is going to take a bounce. This money is going to move from here, it will come here, and then from here it bounces, and then it goes to, for the remainder of the year, it goes to the seventh year. Okay, so how do we calculate this? Using the formula for the compound interest. And now we are going to say, okay, we know that A is equal to what? Is equals to P into 1 plus IN. Okay, so in this case we are going to have two situations. Okay, this money grew to the third year with this interest, and then it accumulated another interest using this interest rate. So at the end of the seventh year, now we are going to have A, which is equal to, what is our present value there? It is 30,000, and you say, okay, 30,000 into 1 plus what is this? How many years here? 3 years. Okay, but what is the interest? The interest is 0.12 divided by 2. Okay, now for 3 years it is what to call compounded half yearly. This is going to be 3 multiplied by what? Multiplied by 2. Okay, and now this amount also, now we are here, we've got a what to call an accumulated value here. This accumulated value here increases with this interest rate. So we are going to say multiplied by what do we have now? For now we have 1 plus the interest rate now is what? The interest rate now is 0.18 divided by 12. For how many years now? For 4 years. Okay, this is going to be 4. So how many months in it? 4 years. So we're going to say times 12, because we are saying times 12 because it is compounded monthly. So at the end of the 7-year period, we are going to have how much? We are going to have 30,000 multiplied by 1 plus 0.12 divided by 2, which is half yearly, to the exponent A times 2. All this multiplied by multiplied by 1 plus 0.18 divided by 12, and then all this for the 4 years, 4 times 12, like that, and then you punch it in your calculator. How much did you get there? No, sorry, this is supposed to be 30,000. I punched 3,000 by mistake there. So it's supposed to be 30,000. So we are going to have, at the end of the 7 year, we're going to have 86,000. We're going to have 86,961,39. So this is the money that we are going to have at the end of the 7th year period. You must remember, if the interest rate changes, our investment will take a bounce from the timeline. Okay, it takes a bounce because the interest is changing there. Okay, now let us look into example 2. Now with example 2, we're told that, okay, Lebogang invest a certain sum of money for 6 years at 16% per annum, compounded quarterly for the first two years, and 15% per annum compounded monthly for the remaining term. The future value of the investment at the end of the 6-year period is 20,000. How much did she originally invest? Okay, so how are we going to get this? We make use of what, because this is also a complicated problem, so we also use what, a timeline. So after for 6 years, okay, so we're going to have something like this, which is going to be our timeline. Okay, now we're going to have 1, 2, 3, 4, 5, and 6. So this is T0, T1, T2, T3, T4, T5, and T6. Okay, so now what is happening is that compound for the first two years. Now we've got a changing interest after 2 years. So now what is our interest for the first 2 years? 16%. Now this is going to be 0.16 divided by 0.16 divided by compounded quarterly. Now this is going to be divided by 4. So for the remainder of the years, we are going the interest rate is going to be 15% compounded monthly. Okay, so this is going to be 0.15 divided by 12. Okay, so and then we are told that the future value of the at the end of the 6-year period is 20,000. So we are here, we've got what, we've got 20,000 there. Okay, now how much did she originally invest? So we're looking for P, the present value there. We're looking for that, the present value there. So how can we get the present value there? So like we said, if we move from right to left, we use the present value, and the exponent is negative. Okay, because what happened here is that this money, it went from here to there, and then it bounced because there was a changing interest, and then it went to 20,000, just like that. Because now we are not moving from left to right, we have to go back. We are looking for that present value there. We're going to use the formula for the present value. Now the formula for the present value is equals to the accumulated amount 1 plus I to the exponent negative n. So this is what we're going to have. Now we're looking for P. What is P? Our present value is going to be how much is accumulated is 20,000. Is 20,000, and then we've got 1 plus, because we're moving from here to there. What is the interest rate? Is the interest rate from here to there is 0.15 divided by 12 for how many years? Okay, for 4 years. Okay, 1 2 3 4 for 4 years. And then this is going to be 4 multiplied by 12, and then we multiply this by what? The next investment is what? Is going to be 1 plus, what is the interest rate now? 0.16 divided by 4. So this was for how many years? This was for 2 years. So this is going to be 2 multiplied by 4, because the investment is quarterly. Now I punch this, all of this on my calculator. This is going to be 20,000 into 1 plus, no, to the exponent. This is supposed to be negative, guys, negative. This one is also supposed to be negative. Okay, -2, because the exponent there is negative. This one is negative, and that one is also negative. 0.15 divided by 12 to the exponent negative 4 times 12 multiplied by 1 plus 0.16 divided by 4 to the exponent negative 2 times negative 2 times 4. Okay, the exponent is negative. This is going to be, so the amount that was originally invested is 8,050 and 11 cents. This is the money that was originally invested. Good people, I hope we are still together with this one. Now let us now look into additional payments and withdrawals. How do we go about solving this kind of problems? Okay, without any waste of time, let us do example with additional payments and withdrawals. Now Modise deposits 5,500 into a savings account. 5 years later, 4,000 is added to the savings. The interest rate for the first 3 years is 14% per annum, compounded semi-annually. Thereafter, the interest rate changes to 12% per annum, compounded monthly. Calculate the future value of the savings at the end of the seventh year. We are also going to make use of the timeline. In this case, we've got what to call changing interest, and also we've got additional payment. Without any waste of time, let us just go straight to our solutions. We're going to have 1, 2, 3, 4, 5, 6, 7. So term 1, 2, 3, 4, 5, 6, 7. Okay, now what are we being told now? 5, how much? It's 5,500 that was initially invested, and then there was an additional of 5 years later, 1, 2, 3, 4, 5 years later, an amount of how much? Of 4,000 was also added. Okay, and now the interest rate for the first 3 years, okay, for the first 3 years, the interest rate is 14. I is 0.14 divided by 14% semi-annually for the first 3 years, and then thereafter the interest rate changes to 12% per annum, compounded monthly. Okay, so I is equal to 0.12 divided by 12, compounded monthly. Okay, calculate the future value of the savings at the end of the 7th year. So we're looking for this A here. So what is going to happen is, good people, what is going to happen is here, we are going to invest this up until to the 7th year. Okay, this 5,500, and we're also going to invest this for 2 years, and then we add the accumulated amounts there. Okay, so what I'm saying is this, what is going to happen, this 5,000 is going to come here, it will increase with this rate, and it bounces to the 7th year. Okay, and this one here will go there, it will just grow with this interest rate, whereas this 5,500 what to call experienced how many interest rate? 2 interest rates, whereas this one only experienced 1 interest rate for how many years? For 2 years. So we are going to add what? We're going to add the 2 there at the end of that, at the end of the year. So how do we calculate this? So we're moving from left to right, so that will be A is equal to P into 1 plus I to the exponent n. Okay, good. So now we're going to say, oh, I'm going to have A as equal to I'm growing this now. This is going to be 5,500 1 plus the first interest rate is this one, 0,14 divided by 2 for how many years? For 3 years. Okay, this is going to be 3 times 2, and then I'm growing it again with this interest rate for 4 years. This is going to be what to call, I'm going to have 1 plus 0,112 over 12 for how many years now? For 4 years. 4 times 12. Okay, now I grew this one. I'm done with this one, so I have to do what? I have to do this one. So because it's additional, it was added, so we have to add. We're going to add this investment. So this investment is going to be with this interest rate. You can see it plays along this interest rate. So this is going to be plus 4,000, and then you see 1 plus how much? 0,12 divided by 12. It was invested for how many years? For 2 years. So this is going to be 2 times 12. 2 times 12. Okay, so all in all, this is going to be equal to, when I say 5,500 1 plus 0,14 divided by 2, and then say 3 times 2 plus multiplied by 1 plus 0,12 divided by 12 to the exponent for 4 years, 4 times 12, and then now we come to this part and you say plus 4,000 into 1 plus 0,12 divided by 12 to the exponent 2 times 12. Okay, so the accumulated amount is going to be equal to how much? Is going to be 18,386 and 28 cents. Okay, so this is how much you're going to get. So it's 5,000, and then this part is covered there, and then we multiply by this. Once you got here, we take it there. Okay, and then we also take this one there, and then we add the 2 for 2 years. Yeah, so the answer is 18,386. Good. I hope we are still together, good people. I hope you understand. If you don't hesitate to ask questions. Now let us do example 4. Now with example 4, what we have, Fifi deposits a birthday gift of 14,000 into a savings account in order to save up for an overseas trip in 6 years' time. At the end of the second year, he withdraws 2,000 rands from the account. How much money will he have saved at the end of 6-year period, assuming that the interest rate for the whole savings period is 8% per annum compounded compounded monthly. Okay, now for 6 years. Okay, so let us say now we are going to also have what, a timeline. We're going to have 1 2 3 4 5 6. We're going to have 1 2 3 4 5 6. Okay, because our timeline will start at T0 1 T2 T3 T4 T5 and T6. Okay, so what are we being told here? We know that a birthday gift of what, of how much, of 14,000 rand here, 14,000 rands. Okay, the 14,000 rands there, and then in order, and then at the end, we're told at the end of the second year he withdraws 2,000. Okay, here he withdraws, you see, minus, because it is withdrawn. Okay, 2,000 rands. Okay, 2,000 rand. So, and then we are told that the interest rate for the entire period, assuming that the interest rate for the whole savings period is 8% per annum, compounded monthly. Now for the entire savings period, we're going to have 0.08 divided by how much? Divide by 12 from here to there. That will be the interest rate. How do I get this 0.08? We say 8 divided by 100. Okay, that's how I got that 0.08. Now this money, this one, is going to grow to the 6th year. Okay, and then this money, also this money, is going to grow to this sixth year. Okay, and then only here, it's only here that we are going to add the 2, but in this case you are going to subtract, simply because this money is being withdrawn, unlike that one, the previous example. We added because money was deposited, it wasn't withdrawn. So let us do this. So we're gonna say a is equal to p into how much, into 1 plus in, and then I'm going to say okay. Now for this one alone is going to be 14,000 into 1 plus 0.08 divided by 12. Okay, it goes for 6 years. It's going to be 6 times 12. Okay, now I'm investing this one. Am I going to add? No, I'm subtracting this one. Now this one is going to be 2,000 into how many years? 1 2 3 4 for 4 years. Okay, so it's going to be 1 plus 0.08 divided by 12. Okay, and then it's going to be 4 times 12. We invest it as a negative, and then we just subtract it there. So at the end of the 6th year, how much is he going to get? He's going to get 14,000, 1 plus 0.08 divided by 12 into exponent 6 times 12, but also minus the 2,000 that was invested, and then it accumulates some interest. 1 plus 0.08 divided by 12 to the exponent 4 times 12. So how much do we get there? Minus 2,000. Yes, so you're going to have 19,837 comma 70. 0.70 rands. This is will be the accumulated amount. This is what FIFI will get at the end of the 6 year period. Okay, hope you understood, good people. So once money is added after some time, you also invest that money, and then once it is withdrawn, we also invest that money, but it's what is a negative money. It's a negative money, it's a negative investment, so we're going to subtract it at the end of the period. Okay, good. Now let us do the last example. The last example will be that of the present value, calculating the present value. Alec takes out a loan to finance the purchasing of a new DVD player. He repays the loan by means of a payment of 5,000 4 years later. 4 years after granting the loan. 2 years later, he repays a final amount of 6,000. The interest rate during the first 4 years of the loan is 16% per annum, compounded quarterly. For the remaining 2 years, the interest rate changes to 14% per annum, compounded half yearly. How much money did Alec originally borrow? So this we have to get the period, total period for the loan. Okay, so we know that 4 years later he paid 5,000. 2 years later he repays a final amount of 6,000, so it means the period for the loan is 6 years. So I'm going to get 1, 2, 3, 4, 5, 6, T0, T1, T2, T3, T4, T5, and T6. And T6. Now, after 4 years, he made a deposit of how much? Of 5,000. And then now, after 2 years, 2 years later, the final amount we paid is 6,000. Okay, now the interest rate for the first 4 years of the loan, the interest rate is what? 16% per annum, compounded quarterly. Okay, and for the remaining the interest rate is 14% per annum, compounded half yearly. So this is going to be 0.14 divided by 2. Okay, now so what happened is that we are now moving from right to left. So we are trying to get that present value there. This is the what to call the movement of the money. Okay, so this one will take this one back here and also take it there. Okay, this one we're going to take this one, we're going to take it there, because we are now moving from the loan. Okay, we are now moving from right to left, and this one we're going to take this one from here to there. Now it's a loan. Okay, so now what is happening is this one will also have to take what? It will have to take a bounce. Okay, because it comes here and then it takes a bounce from here to there. This is the one that takes a bounce. Okay, this one will just take this part of the interest rate. So we're going to use our formula for A. Our formula for A is going to be equal to not for A, for P. We're looking for the present value. Sorry for that. For P is going to be equal to A is going to be equal to A into 1 into 1, A into 1 plus 1 plus what, 1 plus I and negative n. Okay, negative n. So this is going to be we start with which one? We're going to start with this one. Let's start with this one. So this is going to be how much? 6,000 1 plus what, 0 comma 1 4 divide by 2 for how many years? For 2 years. 1 2 for 2 years. It's going to be negative 2 times 2. Okay, because half year. Okay, and then we multiply this part by this one, this interest rate, 1 plus 0 comma 16, okay, divide by 4. It's quarter. Okay, for how many? For 4 years. 1 2 3 4 for 4 years. Now this is going to be negative 4 times 4. Okay, good. Now because we're going in that direction, we added money. It's money added is going to be plus. It's money added is going to be plus. Now plus how much? The 5,000. This 5,000 we could have to get that money there. It's going to be 5,000 into 1 plus which interest rate? This one. Okay, you can see this interest rate. This is going to be 0.16 divided by 4 because it's quarterly. Now for how many years? Also for 4 years as well. This is going to be negative 4 times 4. So this is going to be equal to, we're going to get the present value is equal to 6,000 into 1 plus 0.14 divided by 2 to the exponent negative 2 times 2 multiply by this part now, 1 plus 0.16 divided by 4 to the exponent negative 4 times 4, and then say plus what, 5,000. That was added 1 plus 0.16 divided by 4 to the exponent negative 4 times 4. Now the loan that was taken by Alec is 5,113.44 cents. This is the money that Alec Alec took from the bank. Okay, so I hope you can see this, guys, that for the loan I'm looking for the present value. So we'll be starting from what, from right to left. Okay, as we did with what to call the same thing that we do with the loan is the same as the one that we did with the future value. The only difference is that with the future value we're moving from left to right. With this one we're moving from right to left. And also with the future value the exponent is positive. With the present value the exponent is negative. I hope you understood, good people. Until we meet again, thank you.